In this video, I'm going to show you how to extract Lidar data from the Western DEP website app. Show you how to create a DTM out of that. So, as you can see, we're just going to open a server here really quick, a web page, and we're just going to search for TAGIS, and it'll take us to this link. The link is TGAIS, and then we're going to go to the last button, run the app, and then just navigate to the project location. I'm just going to use our Smith Street location here, and notice there's two sets for this particular location. We're going to want the downloadable one, which is the West Virginia DEP Division of Mining and Reclamation. So we just want to scroll down, and then we're going to download the Bare Earth Lidar dataset LAS file. Okay, so it's going to start downloading, and then we're just going to place this in here in your project file directory. Okay, now one of the things I want to make note of is that you can look at the file formats and the coordinate systems by looking at more Lidar data and description. What you gotta do is transform the data into the state plane coordinate system that we work in. So you can see here that this is a spatial reference 26917, and if we search that in Google really quick, we'll see that it UTM NAD 83 zone 17. So we're going to transform this Lidar dataset from meters UTM zone 17 into our state plane US survey feet. Okay, and we're going to do that using this little application, LAS tools. So when we open this, you can see that there's a whole bunch of files in here, and then we're going to go to the BIN file. We're going to go to LAS to LAS. We're going to run, and it's going to come up with the window here. So you're going to click browse. You're going to specify your C drive or whatever location that your LAS file was downloaded and placed in. You're going to go there, double click on that. We're basically just going to find this this file. Okay, so we're going to double click on that, and then you'll see the blue square screen come up. Then what we're going to do is we're going to define its projection, what it currently is, and we just looked that up online, and it's UTM zone 17 northern hemisphere, and the vertical datum is NAVD 88. Okay, now the next thing we're going to do is we're going to specify the name for it and what directory what file folder we're going to do it and put it in. So what we're going to do is we're just going to use the same one that it came from, and then the file name, I'm just going to say demo for the video here. Okay, then options is left blank. The target projection is going to be state plane 83. We're in Charleston here. We're in the Western State Plane South. Okay, so we're in West Virginia South. We want the units to be in terms of US survey feet. The precision is around 3 decimal places. It's actually a little less than that, but I mean, I just put, and then it's very important that you specify the exporting file to be LAS format, and then we're just going to click run. So it appears that we've had a successful run here, and you can see that within all the files here, demo has been created, 906. So we're good. So that's the first step. Okay, We're going to take that LAS file now and import it to MicroStation and create a DTM out of it. So we're going to open MicroStation drawing. I've created one from scratch here with a seed file and everything. Just labeled it Smith Street. So the data acquisition tool looks like a little data acquisition, like a little total station. It's in the main task menu window here, and we're going to click create surface under the surface command there, and then import external surface Lidar LAS file. So we're just going to click the transpose or whatever file that you created there. And when it comes to this window here, we're going to click the ground because we're going to be evaluating the ground and using it for our design. And then we're going to click the 10 filter. And the Z tolerance factor is kind of how it determines how many points it throws out, because there's so many points. We've got to filter the data, and you got to filter it with the perspective behind how accurate you need the data for your design, whatever you're performing an analysis on or using it for. So I'm just going to put 0.75 for this one in course. So we're going to come up with like a 91% reduction factor. So you can play around with this, whatever you want to reduce the data at. Okay, and then we're going to go ahead and click accept. And now to verify that that was created, we're going to see that the transpose occurs under the surface here. So now we're going to right click on it and export it to En-ROADS DTM. And we're going to save it. So we're just going to save it, Lidar Smith Street DTM, and you are good to go.